Hello, and welcome to our channel, In Wonder. In this video, we will take a closer look at the fascinating topic of how rocky planets are formed. From the collision of tiny particles to the role of temperature, radiation, and gravity, we will explore the different factors that come into play in the formation of rocky planets like Earth. Get ready for an exciting journey through the depths of space and the birth of new worlds. And don't forget to like, share, and subscribe to our channel for more interesting content like this. Let's dive in. What are the rocky planets? Rocky planets are a type of planet that is composed of solid rock and metal. They are found in the inner regions of the solar system and are typically much smaller than gas giants. Rocky planets are formed through a complex process called accretion, which involves the accumulation of dust and gas particles that eventually form a planet. Accretion, the building blocks of rocky planets. Accretion is the process by which rocky planets form. It starts with dust and gas particles gathering in a protoplanetary disk, which is a rotating disk of gas and dust that surrounds a star that is just starting to form. Over time, these particles collide and stick together, forming larger and larger objects called planetesimals. As more and more planetesimals form, they begin to attract each other through gravity, forming larger and larger objects called protoplanets. As the protoplanets grow, they get bigger and heavier, which lets them pull even more stuff from the protoplanetary disk. Eventually, these protoplanets will become large enough to form a rocky planet. Imagine you're baking a giant cosmic cake, but instead of flour and sugar, you're using dust and gas. That's exactly what's happening in a protoplanetary disk, a spinning plate of leftovers from a star's birth. As the dust and gas dance around the plate, they start to stick together, forming little crumbs, or planetesimals. These crumbs then start to attract each other like magnets, forming bigger and bigger balls of dough, or protoplanets. And just like you add more ingredients to your cake batter to make it bigger, these protoplanets continue to gobble up more and more dust and gas, growing larger and heavier. Eventually, these giant balls of dough will become so big, they'll become a rocky planet, just like how a cake becomes a delicious treat. The role of gravity in rocky planet formation. Gravity is the secret ingredient in the recipe for making rocky planets. As protoplanets start to grow bigger and heavier, they become like black holes in the protoplanetary disk. They suck in everything around them with their powerful gravitational pull. It's like a never-ending buffet for these protoplanets as they continue to gobble up more and more dust and gas from the disk. As they get fatter, their gravitational pull gets stronger, allowing them to pull in even more material. It's a virtuous cycle, like a snowball rolling downhill, gathering more snow as it goes. Eventually, the protoplanet becomes so big and heavy that it's no longer a protoplanet. It's a full-fledged rocky planet. And just like how a snowball can become an avalanche, the power of gravity helps turn tiny particles into giant rocky planets. The effects of collisions on rocky planet formation. Imagine a cosmic construction site where tiny protoplanets are like building blocks. As these protoplanets grow bigger, they start to bump into each other. But instead of knocking each other down, they stick together and form one larger planet. Think of it like building with Legos, where you start with small blocks and stack them to make a bigger structure. Just like how a building gets bigger as more blocks are added, these collisions also add more material to the newly formed planet. It's like the planet is a magnet, pulling in more and more building blocks from the surrounding protoplanetary disk. And just like how a building can have different parts added on, these collisions can also cause pieces of the disk to fly off and become part of the new planet. So, in a nutshell, collisions play a crucial role in the formation of rocky planets. They bring protoplanets together and add material to the new planet. Without collisions, we wouldn't have the diverse and fascinating rocky planets we see in our solar system and beyond. The formation of rocky planets in different solar systems. The formation of rocky planets can vary depending on the type of solar system they are found in. In some systems, like our own solar system, there is a lot of dust and gas in the protoplanetary disk, which makes it easy for rocky planets to form quickly. In other systems, such as those with fewer particles in their disks, rocky planets can take much longer to form. Additionally, some systems may lack enough material for rocky planets to form at all. Imagine you're trying to bake a cake, but you're in different kitchens with different ingredients. In some kitchens, you have all the ingredients you need, like flour, sugar, and eggs, and the cake will be baked in no time.
Oh God, it's so good.
This is like a solar system, with a lot of dust and gas in the protoplanetary disk, where rocky planets can form quickly. But in other kitchens, you might be missing some key ingredients like sugar or eggs. You'll still be able to bake a cake, but it will take longer. This is like a solar system with fewer particles in the protoplanetary disk, where rocky planets can take much longer to form. And in some kitchens, you might find there are not enough ingredients at all. In this case, you won't be able to bake a cake. Similarly, some solar systems may lack enough material to form rocky planets. So the formation of rocky planets can vary depending on the type of solar system they are found in. The role of temperature in rocky planet formation. Temperature also plays an important role in the formation of rocky planets. As protoplanets get bigger, their gravitational pull and collisions with other things cause them to heat up. This heat can cause the material in the protoplanetary disk to become more energetic, allowing it to move faster and increasing its chances of being added to the growing planet. High temperatures can also make some materials evaporate, which reduces the amount of material that can be used to build. Think of it like building a sandcastle on a beach. As you pile up more sand to make it bigger, the sandcastle gets hotter and hotter. This is like how protoplanets get bigger. Their gravitational pull and collisions with other things cause them to heat up. Just like how heat can make the sand on the beach more active, causing it to move faster and making it easier to shape the sandcastle. The heat from the protoplanet can make the material in the protoplanetary disk more energetic, allowing it to move faster and increasing its chances of being added to the growing planet. But too much heat can cause the sand to dry out and make it harder to shape the sandcastle. High temperatures can also make some materials evaporate, which reduces the amount of material that can be used to build the planet. So temperature plays an important role in the formation of rocky planets, just like it plays an important role in building a sandcastle. The effects of radiation on rocky planet formation. Radiation from nearby stars can also affect the formation of rocky planets. Some of the materials of the protoplanetary disk can become ionized when there is a lot of radiation. This makes it more likely that they will be pulled toward the growing planet by its gravity. Radiation can also cause some materials to evaporate or be thrown out of the disk, reducing the amount of material that can be added to the star. It is like building a snowman on a sunny day. The bright sunlight can cause some of the snow to melt, making it easier to shape and add to the snowman. But if the heat is too much, it can cause the snowman to melt. Radiation can also cause some materials to evaporate or be thrown out of the disk, reducing the amount of material that can be added to the planet. So, radiation plays an important role in the formation of rocky planets. In the end, rocky planets are made through a complicated process called accretion, in which dust and gas particles build up to form a planet. This process is aided by gravity, collisions, temperature, and radiation from nearby stars. The way they form can be different depending on the type of solar system they are in and how much matter is available to accrete. To learn about our solar system and other planetary systems in the universe, we need to know how rocky planets are made. We hope you found the information and tips we shared helpful. If you enjoyed this video, please give it a like and share it with others who might be interested. And don't forget to subscribe to our channel for more interesting content like this.